A world without mining would not exist. Our civilization would stop. Some people that say recycling is the solution. And in 100 years, it may well be. By 2040, the estimates are maximum 10% of all the nickel we need in 2040 will come from recycling. And today it's less than 1%.
What was the vision behind it, and how does the technology work?
So what we did is say, well, what if we took a 21st century approach? How could we design a collector system using all this new technology, robotics, AI, computer vision, batteries, autonomy, and do it in a way that preserves the habitat?
What are those points that you're hearing where people have objections to the way in the type of industry you're in, and how are you overcoming them? Welcome listeners, I'm Seb Wichmann, your host of the Do Good Insider, where we dive deep into raw and meaningful conversations with visionary founders and CEOs who see beyond profits, elevating the lives of employees and vendors and the planet we call home. Today we are joined by Oliver Gunasekara, a remarkable entrepreneur who's making waves in sustainable technology, quite literally, as the CEO and co-founder of Impossible Metals. Oliver's journey reads like a masterclass in transformative leadership. From being around the 60th employee at ARM, where he helped drive mobile market share from 0 to 95%, to successfully founding and exiting NG Kodak to AMD, Oliver has consistently pushed the boundaries of what's possible in tech. But it's his latest venture that truly captures the spirit of purposeful innovation. As the founder and CEO of Impossible Metals, Oliver is revolutionizing deep-sea mining through AI-powered robotics, proving that environmental responsibility and technological advancement can go hand in hand. His transition from semiconductor technology to sustainable ocean mining exemplifies the kind of bold leadership needed to address our world's most pressing challenges. Today, we will explore how Oliver navigates the complexity of building a purpose-driven company while fostering a culture of innovation and environmental stewardship. So, Oliver, I'm super excited to having you on this podcast. And the reason being is that Impossible Metals, to me, does such a remarkable job and has such a purpose-driven and sustainable vision, looking at deep-sea mining and looking at rare metals. Yet there are many parties where you face resistance in the way they perceive deep-sea mining. Questions are in the room of, how you protect corals and other aspects. And I wanted to bring you on because you are on the forefront of technology, sustainability. And I know that deep in your heart, you care deeply about these matters and these points that the world are stressed by, if you will. And other companies can certainly relate. Talk us through, how do you communicate the values and vision of Impossible Metals and conquer this resistance that you get from opponents?
Yeah, it's great to be here, Seb. Thank you for the opportunity. And, I think it all really starts with what's our core mission. What is it that we're trying to do? And then that fundamentally is about delivering sustainably harvested critical metals to enable this energy transition. And as you said, it's a very controversial space. There's a lot of NGO and opposition to the concept of deep sea mining. The idea that we have mined a lot on land and there's a lot of environmental destruction, there's a lot of social and human rights violations. And should we now go to another part of our planet that's pristine, we haven't touched, and now do bad things there? And I understand it. And to be honest, I was kind of in that camp. When I looked at the technology that everyone else was focusing on, what shocked me was that fundamentally it was invented in the 1960s, tested in the 1970s in the deep ocean, and hasn't really changed. It's fundamentally a dredging technology where a big collector machine is vacuuming up the seabed floor. And, that has negative environmental consequences. And so what we did is say, well, what if we took a 21st century approach, a blank sheet of paper, first principles? How could we design a collector system using all this new technology, robotics, AI, computer vision, batteries, autonomy, and do it in a way that preserves the habitat, but still collects some of the metals that we desperately need? And that was really the reason we started the company. Fortunately, having done a few startups prior, we decided to do a few things from a sustainability. We decided to be a B corporation, a public benefit. So, not only do our directors have to think about maximizing shareholder value, but they also have to support our public benefit, which is delivering these sustainable metals that we all need. And we also set up something called Pledge 1%, where we put 1% of our shares into a trust that we will at some point donate to a nonprofit. We've committed 1% of our profits and we volunteer 1% of our time. So we're really trying to do it differently. But it is super challenging because you have most of the world opposed to deep sea mining because of the older technology, and us being a new player and a small player, it's difficult to kind of raise and get our message out.
Talk us through what are some of those points that companies have resistance for? What are they saying? What are those comments? What are those points? Let's just raise them to also draw awareness, because there's so much, there's so many assumptions out there, not just in your field. We kind of have seen things being done in certain ways, whether or not that's education or whether or not that is sustainability or entrepreneurship. The new kids on the block are always the ones, so to speak, that first of all need to push through this immediate kind of point of resistance to re-educate people. What are those points that you're hearing where people have objections to the way in the type of industry you're in, and how are you overcoming them to re-educate those people?
Yeah, I think it starts with mining. We all know mining. It's been around basically ever since there were humans. We've labeled things like the Bronze Age. Mining has been fundamental for human civilization, and it is today. If you look around, if it wasn't grown, it was mined. And so a world without mining would not exist. Our civilization would stop. So mining is fundamental to our modern way of being, but it has big problems. Historically, it hasn't been particularly well regulated. There are very well documented human rights violations. There are artisanal miners, often teenagers, that are digging tunnels in Africa to get material and getting paid $1 to $2 a day, often being injured, sometimes being killed. There are people being forced off their land, often indigenous people with no choice. Soldiers come and say, this village is now mine, go. There's pollution. Often mining generates a lot of carbon, but also there's a lot of acid and other harsh chemicals used in the mineral processing. And that leaks into the water supply, it pollutes the land, it kills the fish. So these are human issues, social human rights issues. But then there's the environmental issues that many of these metals are found in high bioverse rainforest areas. For instance, nickel, something like 65% of the world's nickel today is mined from the Democratic Republic of the Congo in Africa. And unfortunately, the nickel laterite ore is directly below the rainforest, like a meter or so. And so you have to deforest a complete rainforest to get at this ore. And if you look at satellite images of Indonesia, all these islands, all these rainforests are now just turned into mines, open pit mines. And that's a terrible result. And, the problem is that people don't really know about this, that the nickel that they use, whether it's in stainless steel or whether it goes into a battery, probably came from a rainforest. And so we have to do better. And the thing with the seabed is that there's a huge quantity and there hasn't been mining. So there's an opportunity to do it in a completely different way. And as I mentioned, our competitors are dredging, and people get very concerned because there is obviously much less life than a rainforest. In fact, most of the life in the deep ocean, we're talking 4 to 6 kilometers deep, and we're talking these round potato-sized rocks that lie on the seabed floor. But there isn't a huge amount of life that lives down there because it's a low energy environment. No light from the sun goes more than a few hundred meters. But the life that does exist is very unique and special and needs to be preserved. And so that's why we designed this hovering robot that uses cameras and AI to look for a deep sea sponge or a coral. And if we see it, we skip it, versus a dredger that will just remove absolutely everything, including the sediment. The seabed sediment actually has the majority of the life, which is the bacteria. So that's really where we come from. Mining is essential. There's no way we can do without mining. There are some people that say recycling is the solution. And in 100 years, it may well be. But today, the demand curve for nickel is that we need, in 2030 and 2040, millions of tons of more metal. And recycling will just do a tiny fraction. I think by 2040, the estimates are maximum 10% of all the nickel we need in 2040 will come from recycling. And today it's less than 1%. So recycling, if you take 50, 100 years, could be a solution, but it doesn't meet the demands we have right now for the energy transition. And so we've got to do mining. And our view is we should do it where we can have the least impact with the most advanced technology that actually preserves the habitat. We will leave 30% behind at the same time we mine. And that's our view. But it's hard to get that message out.
Yeah. You just alluded to the point that the world needs more raw precious metals, nickel, cobalt, aluminium. I'm not an expert, but I believe I called out the right type of metals. What made you look into kind of establishing impossible metals? What is the need that we all want, being it EVs or other technological advancements, where we need to think about, okay, how do we actually go about bringing in those raw precious metals to manufacture them? What was the vision behind it? What was the reason why you established impossible metals? And how does the technology work?
Yeah, great question. So I wanted to start by describing the resource. So what I'm holding up here, for those that have the video, this is called a polymetallic nodule. So it's a potato-sized rock, and these form in the trillions, and they just lie on the seabed floor. So this is the ore that we're trying to pick up. But unlike the nickel laterite ore that's below the rainforest, it's not attached. There's no cutting or blasting or tunneling. Literally, these are potato-sized rocks that just lie flat on the seabed floor. And what's exciting about these rocks, and this one is from the Pacific Ocean, close to Hawaii. This is from the Cook Islands, which is a long way south from Hawaii. And it's a little bit different. But what's really nice about these nodules is that they always contain 4 metals: nickel, cobalt, copper, manganese, and some rare earths. And the percentages vary, but it's generally a high-grade resource, which makes it very economic. And, one of the nice things about those metals is that these are some of the most important metals for the energy transition. So let's talk about copper. Copper is used wherever there's electricity. Any wiring is basically copper. We need massive amounts of copper. If you look at cobalt and nickel, these are used in batteries, so when you store the energy, but they're also used in the generation. So things like solar, wind, nuclear power, even a gas turbine will use these metals. And so when you look at the electrification's supply, whether it's from generation, transmission, storage in the form of a battery, or usage in the form of a motor, all of them need these metals. And so that's why I got attracted to this, because without enough metal at the right cost, there's no way we will electrify. There's no way we will get to net zero. And so it becomes actually one of the biggest barriers. And it's not just a matter of getting the metal, it's getting it at the right cost point, because the biggest cost of an electric vehicle today is the battery. And the biggest cost of the battery is the metal, the nickel and the cobalt that goes into the battery. So by providing a huge quantity of these metals at a lower cost, we can make it cheaper for people to afford clean energy, to afford electric vehicles and solar power and other forms of energy that's needed for the transition.
Mm-hmm. And so if I imagine right now, there is a machine, a robot going 4 to 6 kilometers down with little arms. You tell me that's how I'm visualizing this, but with little arms, and kind of via AI scans the ocean floor, identifies a coral from this mushroom-looking stone or potato-looking stone, and collects it and puts it in its belly, puts it in its tray, puts it in. Is that how? Talk us through, like, how do we imagine that?
That's exactly right. And hopefully we can give you a link to a YouTube animation and a video of the real vehicle for the show notes. But fundamentally, these robots, in fact, the one we're designing now, which is our production size system, we call it Eureka 3, is the size of a 20-foot shipping container. So imagine a 20-foot shipping container on its vertical end. So it's up vertical, and below it is an array of 12 arms. And these are mechanical arms, something that you might see in a pick and place factory that's picking an object up and placing it somewhere. So they're really designed for speed. And what this vehicle does is it is launched from a ship, and then it dives using some buoyancy technology that we developed that allows us to pump water inside these buoyancy vessels that make the vehicle heavier. So it dives, but it never lands. So it hovers about 2 meters above the seabed floor. And it uses some lights and cameras, and it looks at each one of these nodules. And it's looking for 3 things. It's looking for what is the seabed, what is a nodule, and what is anything else. And anything else we assume is life. It could be a deep sea coral, it could be a sponge, it could be there's a species of octopus that lays some eggs, there are some worms, there are quite unusual and very unique life that are down there. But anything that is above maybe a few millimeters, our cameras can detect. And if we see anything that isn't seabed or a nodule, we assume it's life. We don't need to classify it. We just say that is life. We want to preserve it. And what we do is don't touch it. We put a green circle in our animation. You can see on our website. We'll put it in the show notes. And there's a quarantine area put around the nodule. And anything within the quarantine area will not be disturbed. The vehicle will just fly directly over the top and not touch it. And in addition, because we know that things like corals and sponges, these are pretty rare. From the surveying data that's been done, about 1%, every 100 nodules has what we call megafauna, something that you can see with your eye. Now, they all have bacteria and smaller life, but something you could see with your eye, about 1%. And that's what we're looking to detect. But in addition, we have decided that we will always leave 30% undisturbed. So 30% will always be undisturbed. And we think that's really great for complying with some of the biodiversity agreements that people are having. And that will maintain the viability of the habitat so that when that octopus comes by to lay its eggs, there are some nodules there. Now, if the dredger had gone across, all the nodules are gone, 100%. And so when the octopus wants to lay its eggs, there's nowhere for it to lay its eggs. But in our case, 30% of the nodules are preserved, and that includes islands of life where we've detected it using the AI on the vehicle.
When I'm listening to this, it sounds very well thought through. The technology is to me, it sounds you are looking to, preserve life. It's very intentional in its function, design, purpose, vision. This is just, a total somebody who doesn't know much about it, right? Now, I would like to just revert back to our conversation, the opposition. People that think about and kind of hear the word mining and immediately bring up, destruction and whatever happens in their minds. For other companies going through not the same questions and concerns that your opposition goes through, but we as entrepreneurs, we always have some sort of, people that have concerns of free speech or whatever it is. How do you go about, I wouldn't say silencing, but counteracting, explaining, re-educating, and maybe better words, the people that have power in the world to maybe even shut you down or not? How do you combat this from the standpoint impossible metals, but also, finding relevance to other companies? What are those ways that you go about this?
Yeah, it is probably our biggest challenge, but the way we are approaching it is to basically be transparent and open. Our default is that we share everything. We share our successes, our failures. When we do things, we publish information, we make it available on our website. We try to just be as open as we can so that people can come and see. And we know it's a difficult trade-off. We desperately need these metals. There are some, as I said, that will say we can recycle our way out of this problem. We can't, not in the next 50 years. The demand curve is so steep, and we can't substitute either, because each metal has specific properties, the reason why it's used. There are trade-offs. If you move to a different type of battery, it's a lot heavier, which means you get a lot less range. So, the reality is there isn't going to be substitutions. We can try to reduce demand, but is it fair to tell someone in Africa or India, you can't have air conditioning or you can't have an electric vehicle because we're using too much? I don't think that's ethical. And, certain countries, well, maybe in the US, ideally there would be one car per family, not two or more. But the US doesn't have the infrastructure. It hasn't built out public transport. In a European city, that maybe is practical. But so the reality is we desperately need these metals. So the choice is, where do we get them from? Do we get them where we get today, which is, 29% of the planet, which is land? That's where we get where all the people live. It's, that's where we get all the mined materials from today. Or do we go to the 71% of the ocean, which is the ocean, which we haven't touched? And do we use really advanced technology like ours to preserve the habitat? And I am completely convinced that if you take the view of getting the metals with the least impact, the deep sea has compelling advantages. It's also going to be far less expensive. And that, again, is important because the cost of the metal has a knock-on effect of affordability, which will have an effect of how quickly we can decarbonize and move to electricity. And, because we haven't done mining yet in the ocean, we have great resources, high grade, 4 metals, and we don't need new infrastructure. We just reuse ships and ports. On land, because we've been mining forever, all the good stuff's already gone. What you're left with is this low-grade stuff that is going to be far more expensive to extract, and it's in very remote locations. So you have to build roads, you have to build power plants, you have to build accommodation for workers. All of this has to be constructed and paid for. So the beauty of the ocean is not only we can do it with less environmental impact, no social impacts, we can do it at a fraction of the cost, and we can do it a lot quicker. That, to me, is super compelling.
Yeah, thank you for that. So really, what I'm hearing from you, it really boils down to this utter transparency, openness, sharing information the way you can, to create a open environment where you probably also welcome some questions and improving the services, how you go about things, and just this piece around re-education, which is so normal, I think, for technologies in particular that are new, right? So I want to shift topics here a little bit. I believe Impossible Metals is a all remote culture. Is that correct?
It's not completely all remote, but we do have a large remote, maybe about 50%. So we have a robotics lab in a city in Collingwood, which is north of Toronto in Canada, and about a bit under 50% of our people are permanently based, and the rest are remote. But we typically come together once a month or so.
So speaking about a hybrid culture of remote staff, some of them, in the lab, so to speak, or in the office for other companies, talk us through engaging staff, aligning staff, pulling on the same string to moving things ahead. How do you go about this? Like, talk us through your ways of staff engagement, of building relationships. It is nowadays so normal for us to sit there via video, but it doesn't yet constitute or supplement or replace this touch on the shoulder saying, hey, buddy, well done. You did really well. Thank you so much for your effort. How do you go about that?
Yeah, I think it starts with the hiring process, and we look for people that are mission driven, that believe in the mission, that understand that ultimately this is about doing good things, about making a difference, and that I think is really important. Of course, when you're hiring engineers, as are the majority of our team, it's also about having real technical challenges and doing things that others haven't done. But that is pretty key. But I think you just have to work at it. You have to have opportunities to bring everyone together as often as you can in person. But you also have to do all hand meetings. You have to do random chats where you can just reach out to colleagues and get connected and talk to them. But it is important to bring people together and to be periodically everyone on site together, talking about what we're doing and building those relationships. Another thing I think that's really important is you got to celebrate the wins, the successes. Startups are really difficult. It's everything's against you, and a tradition that actually I inherited from ARM days. ARM had this idea that every time they made a new chip and it worked, we would pop a bottle of champagne, and then you drink it, but then we would store the bottle, we'd write the date and the reason. And it used to be, I don't know if it's still the case, you'd walk in their lobby and you see this whole row of champagne bottles and the dates and what it was. And so we have something similar now. If you were to come to our lab in Collingwood, we have a row in one of the meeting rooms of these bottles of champagne with a little label of when we did it. And that's, again, I think, it's so important to celebrate the wins and successes, because a startup journey is a hard journey. All the odds are against you, and often, like us, we're kind of breaking into a new industry. Like, we kind of come from outside of deep sea mining, but we had these ideas, and so you basically get resistance from people that are in the space that kind of say, "Oh, that will never work," as well as the traditional. People are always skeptical of startups. So I think, getting people to celebrate the wins, hiring for culture, and then having as many opportunities to have face-to-face interactions as well as the virtual all hands meeting is really critical.
There are so many companies, I would say, almost the bigger ones, the small, medium enterprises, upwards of 1,000 people plus, where culture really starts to become more and more important. In today's world, where, not just post-COVID, but also, as it has fast-tracked the whole digital era of Zooms and all that a couple of years ago, to me, it becomes more and more normal for us to just have virtual meetings, and we may not go into the office or see each other face to face all that often. I still remember a time during the pandemic where I remember this meeting, this lunch I had with a friend of mine, where I suddenly thought, wow, that is how it feels like to really meet somebody, to actually look somebody in the eye and almost like have a human touch, right? And culture or business, the way we look at it through the lens of Do Good Agency, is that a company is nothing more but a bunch of people with a bunch of brains that have certain needs and that perform in a certain environment. You can't expect to kind of, plant a rose on concrete and expect that rose to flourish and grow, right? So the question to companies I pose is, how do we go about nurturing this, what we believe is the most important asset of having a company grow or not, which are the people. And it's so crucial to have a distinct strategy and approach to how do you build relationships, how do you build culture of excellence, how do you build high-performing teams, aka people that really work really well together to move towards this common objective and vision that moves the company in a way that's where the company wants to move towards too. So super, super important, no? Oliver, thank you so much for your time. It has been an absolute pleasure to meeting you, to listening to your ways of working with impossible metals. Even though I'm not familiar with deep sea mining, what I'm listening out for are companies and leaders that, when I listen to those people, have thought through what they're doing. There is a vision, there is purpose, there's intentionality. They usually are open to listening to feedback and are calm in moments to explain the thing that most people's or opposition don't understand in a calm manner, very realizing that, there are people that have seen things through mining, in your example, for example, that didn't always go that well, right? So I really want to thank you for making the time for people of concern to calmly explain what you guys do, for being open, for being transparent, and doing the great job that you guys do with lots and lots of intentionality and purpose. So thank you so much for your time, and I wish you a wonderful day.